Assalamu alaikum dear student, this is Wajid Alisha and today we are going to discuss the topic energy stored in a capacitor, which is given on page number 47. So as we have already discussed in the previous lecture that capacitor is used for storing electrical energy in its electric field between the plates. In this topic we are going to explain that what is the amount of that energy, and that energy depends upon which factors. So energy stored in a capacitor can be written in equation form like U is the symbol for energy, 1 over 2 Q into V. This is one form of the equation. Another form of the same equation can be written like 1 over 2 Q divided by C. As we know that V is equal to Q divided by C, so one Q is here and another Q is placed instead of this V, so we can write it 1 over 2 Q square divided by C. Third form of the same equation can be written like 1 over 2 CV square. As we know that Q is equal to CV, so putting the value of Q we can modify the equation into this 1 over 2 CV square. Or another form of the equation can be written like U is equal to 1 over 2 epsilon naught epsilon R E square. So there are different forms of the same equation. We can modify the equation having one or another, or the next one, shape of the equation. Second, this is third. So in this topic we are going to derive these equations. So for the derivation purpose we can have that we connect a capacitor of capacitance C to the power supply to the battery like this, as shown in the figure. This is capacitor C and this is the power supply. Terminals positive and negative. Positive is used for high potential, negative is used for low potential. The potential difference applied here to the battery will finally charge the capacitor. So as we have already used the concept of electric potential in previous lectures, so we can write from this equation that the work done by taking the charge Q using the energy of the potential difference can be written like this: W is equal to Q into V. W is used for work done. This is a very important point, that whenever we want to find the energy of the system, we need to find the total work done on that system or by that system. So W is equal to Q into V. W is used for work done, Q is used for charge, and V is used for the potential difference of the battery. So as the charges initially on the capacitor are 0 and the voltage of the battery is maximum initially and the voltage on the capacitor is 0. Initial voltage of the capacitor is 0. As gradually the charges are going toward the capacitor and the voltage of the capacitor increases gradually, so that's a variable concept. So we can use the concept of variable voltage Q into V average. As the voltage across the capacitor is variable, initially it is 0, finally it is V, so we can take the concept of average voltage. So average voltage is taken as, we know that average voltage is equal to initial voltage plus final voltage divided by 2. So initial voltage is 0 on the capacitor and final voltage on the capacitor is V. So we can have the concept of variable or the average voltage, and the total work done comes out to be Q into 1 over 2 V. This is average voltage of the capacitor. Now, further, we can use that total work done is equal to 1 over 2 Q into V. This is one form of the equation of the energy. This is the total work done on the charges by charging of the capacitor. And as we know by the principle of work energy principle, the concept from class first year, so we can write that total work done is equal to total energy, potential energy, electric potential of the capacitor. So we can write the energy stored by the capacitor like this equation. This is one form of the equation. Similarly, to derive another form of the equation, as we know that Q is equal to CV. So putting this value in above equation, we can write U is equal to 1 over 2 and CV square. This is another form of the equation. Again, as we know that V is equal to Q divided by C. So putting this value in above equation, we can again modify the equation like writing 1 over 2 C, and in place of V we can write Q divided by C whole square, or 1 over 2 C Q square divided by C square. So cancelling 1 C from numerator and denominator, finally we have 1 over 2 Q square divided by C. This is the total amount of energy stored between the plates of capacitor in the form of electrical energy. These are different shapes of the same equation, different forms of the same equation. Now, having a new concept of electrical energy in itself, we can have that, as we know that, modified form, that is, we know that V is equal to E into D from the concept of potential gradient. This is V potential difference, this is E electric field intensity of the electric field between the plates, and this is the D. D is the distance between the plates. Again, we have used the concept of what? Capacitance. In previous lecture, previous topic, this is equation 1, this is equation 2. Capacitance of the parallel plate capacitor like this. Equation 2. Putting these two values of V and C in this form of the equation, like total energy is equal to 1 over 2. Instead of C, we can put this value, epsilon naught A divided by D. And instead of V, we can put this value, E into D whole square. So, rearranging the equation, 1 over 2 epsilon naught A divided by D into E square into D square. D will be cancelled from denominator with one of the numerators. So 1 over 2 epsilon naught A E square into D. We can write 1 over 2 epsilon naught E square A into D. Now, what is A, what is D? A is basically the area of the plate of capacitor, like this. This is area of the capacitor plate, and this is D, distance between the two plates. And this, the product of A and D basically gives us the volume of the space occupied by both the plates of capacitor. So it gives us the concept of volume. So this is U, capital U, used for electric potential, 1 over 2 epsilon naught E square into V. We can now change this concept into energy density, and that is denoted by small u. Small u is equal to capital U divided by volume. Energy, total amount of energy divided by total volume, and that comes out to be 1 over 2 epsilon naught E square. So this is another form of the equation of the energy used for capacitor. So U is equal to 1 over 2 epsilon naught E square. This is another modified form of the equation for energy stored in a capacitor. Keep in mind, boys, that there is a difference between capital U and small u. Capital U represents the total amount of energy, and small u represent energy density, energy divided by total volume available. That's all. Thank you. If you have any questions, so let me know through the WhatsApp group or in comments section below. Thank you.